Hello everyone, let us try to see minors, cofactors, adjoint and inverse of a square matrix. What you see here on the screen, it is a 3 by 3 matrix. 3 by 3 square matrix. The first number 3 represent the rows and the second one represent the column. Rows are the horizontal one and the column are the vertical one. So this is a square matrix anyways. So let us see how to find minors, cofactors, adjoint and inverse of the square matrix. From all these, the minor one is the easier one. How to find minor? Here is the example. For example, when we are saying minor 1, 1, the first row and the first column will be cancelled and the remaining 2 by 2 matrix will be taken. Then the determinant of this will be the minor 1, 1. But when we say the minor 1, 2, let us see it, the second one. Look here. The minor 1, 2. The first row and the second column, because 1, 2. The first number represents the row, first row, it's here. And the second number, the column, second column will be cancelled. Then what left? 2, 1, A1, A21, A23, it's here, taken. And A31 and A33, it's taken here. This is minor 1, 2. So the same pattern, you will proceed. And then for 3 by 3 matrix, you can have 9 minors, as you see here. All of the minors are written here. So calculating minor, it is a very simple one. And the pattern or the process will be the same. But cofactor a bit different. It is the same like minor. Cofactor is sensitive on signs. So those signs, simply what to do? Positive, negative, positive, negative, positive, negative, positive, negative, then positive. Make it. That means the positives will not be changed. The positive areas, no change. So start by positive anyways. Start here by plus. Then continue. That means the first minor 1, 1 is the same as cofactor 1, 1. The reason, because 1 plus 1 is 2. The sum 1 plus 1 will give you 2. That is even number. In case of even number, the minor and the cofactor will be the same. But for simple one, for the simple process, like for the shortcut, what I'm telling you, first find the minor. And then the first number, leave as it is. The second one, negate it. The second, leave as it is. The third one, negate it. The fourth one, leave as it is, then negate it. Just by skipping 1, 1, negative, positive. Start from positive. Then positive, negative, positive, negative, positive, negative. This is the pattern. Let us see the example, because example, mostly in mathematics, example clarify much better. Let us see the example below here. Here it is. This is a square matrix. It is 9, 2, 1, 5, negative 1, 6, 4, 0, negative 2. So minor 1, 1, how it's found? First column and first row is cancelled. So what left? Look it out here. Negative 1, 6, 0, negative 2 left. Then find the determinant of it by crisscross multiplication. This is minor 1, 1. Then minor 1, 2, it's here. I hope you can find this. And then minor 1, 3. It continues in this manner. So that the total number, like the full number will be the minor. Let's get it. Two, then negative 34. The first number is 2, then negative 34. Then what? 4. Then negative 4. Then negative 22. Then negative 8. Then 13. Then 49. Then finally negative 19. These are the minors. Take time and practice with it. Very simple. When we are saying minor, 1, 1, cancel first row, first column. Take the 2 by 2 matrix and the determinant. And when we are saying 1, 2, first row and second column will be cancelled. And take the remaining 2 by 2 matrix and then calculate the determinant. When we are saying 1, 3, the first row and the third column will be cancelled and the remaining 2 by 2 matrix will be taken and the determinant. In this pattern, it will go down. Then finally, construct a 3 by 3 matrix. As you see here, this will be the minor. This is a minor. But how to find the cofactor? The cofactors is the main important thing here, what we need. To find the cofactor, the first one leave as it is, and then negate, then as it is, then negate. Go like that way. So the first will be taken as it is means we will take it 2 as it is to find the cofactor. Okay, to find the cofactor, imagine now I will take 2 as it is. What is the next number? The next number is negative 34. So I will negate it. It will be positive 34. Okay, the next one, 4 as it is will be taken. And again, I will take negative of the next number. The next number is negative 4 here, as you see. So negative 4 will be negated, which will be 4. This is cofactor, imagine. And then negative 22 as it is will be taken. And 8, negative 8 will be negated, which will be 8. And the last numbers, the last rows, 13 will be as it is. And then negated the next number, 49. And then the next will be as it is, negative 19. This is a cofactor. So why we need the cofactor? The main point I told you, the cofactor. Because when we are trying to find the inverse of any matrix, 3 by 3 matrix or any square matrix, we need the cofactor. There is a formula for the inverse matrix. But first of all, let me tell you what means adjoint of a given matrix A. Mostly represented by AH, adjoint of a given matrix A. Consider the above matrix is matrix A, original matrix. This one, let us consider as matrix A. Let us make it clean and let's make it visible. Here, let us consider this matrix, matrix A. The number is 9, 2, 1, 5, negative 1, 6, 4, 0, negative 2. This matrix, consider it is A. So we are trying to find the inverse of it. So first we have to get the adjoint. The adjoint of a given matrix means, here it is, I started. The adjoint of a given matrix means it is the same as the cofactor transpose. Transpose the cofactor. Where is the cofactor? The cofactor already, we got it here. So that transpose means, you know, the first column, you will make it as first row. So what is the first column here? The first column, it is 2, 4, 13. We will take it as a first row. And then just inverting. So let's find. 2, 4, 13 will be 2, 4, 13 will be first row. Okay, the second column, what you see here, the second column, this one, it will be taken as second row. 34, negative 22, and negative 49. 34, negative 22, and negative 49. We are transposing the cofactor. Because the transpose of the cofactor, as I told you here, the transpose of the cofactor will be the adjoint of the given matrix. So we are transposing. So at last, the last column, that is 4, 8, negative 19. 4, 8, negative 19 will be the last column. 4, 8, negative 19. We are done on the adjoint. Okay. Remember, till now, what we discuss or what we make clear, it is minor, then cofactor, then adjoint. We already discussed everything. Minor, it's very simple. Like in every entry, cancellation. For example, minor 1, 1 means cancel this and take the remaining. And minor 1, 2 means cancel here and take the remaining. The determinant, remember, the determinant of the 2 by 2 matrix. In that manner, you'll find the minor. And then the cofactor means positive, positive, negative, positive, negative. That means the first one, no change, the second will be negated. And the third one, no change, the next will be negated. In this pattern, you will continue to find the cofactor, like I did. Then finally, let's go to inverse, the inverse formula. We have got the cofactor. This is adjoint of A. Remember, this is the adjoint of the given matrix A. Okay. Therefore, the inverse of a given matrix, the formula is equal to the adjoint of the matrix, divided by or over the determinant of it. Previous lesson, we have seen how to find determinant of a 3 by 3 matrix. It has its own method. But remember here, if the determinant becomes 0, if the determinant of the given matrix becomes 0, means it has no inverse. It has no inverse. We can conclude it has no inverse. But if the determinant is different from 0, the given matrix will have inverse. And how to find the inverse? First, we need to get the adjoint. The adjoint is time taking because first we have to calculate the minor and then the cofactor. Actually, minor and cofactor are related. And then when you arrive at the cofactor, you need to transpose it to get the adjoint. Then once you have the adjoint, divide by the determinant. But before you start finding the inverse of a given square matrix, first check the determinant. If the determinant becomes 0, no need to waste time because the given matrix will not have any inverse. That's it. Thank you so much.